She brings life on our planet. He is the outer world object that humans entered for the first time. Both infuse our lives more than we expect. From the brightest object in our solar system to the space race in the 1960s, today we explore the Sun and the Moon.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the Moon and returning him safely to the Earth.
The Sun, its winds and storms, influence the whole solar system. The Sun is the source of life, and yet we ask ourselves, what kind of object is the Sun? Our Sun has a core with a temperature of around 15 million degrees. Nuclear reactions in the core burn hydrogen to helium. This energy is released as radiation. This complex and exciting process already begins about 200,000 kilometers below the surface, where the first swirls of matter take place. There, the magnetic field of the Sun is born. What we perceive as sunspots on the surface are individual magnetic fields, of which only the strongest are visible. The entire magnetic field of the Sun is never visible. Let's imagine the Sun as a dynamo. It rotates, but not evenly. It is a vibrating gas ball, which is ensured by the sound waves that are reflected inward and reflected back from the core. What we perceive as the surface of the Sun are so-called convection zones. The ascended heated matter streams in these zones are so-called convection bubbles, which cool down and fall back into the Sun. This process can also be perceived as bubbling. Above the convection zones, the Sun's corona is formed. As the North and South poles reverse their polarity every 11 years, it means that the Sun completely reversed its polarity once in 22 years. The sunspot cycle also follows this routine and lasts 11 years as well. In 2022 and 2023, there will be a particularly large number of spots on the Sun. At the time of Galileo Galilei, mankind gained the first insights about the Sun. In the 18th century, sunspots were already examined and counted. Carl Friedrich Gauss and Alexander von Humboldt have already studied the Earth's magnetic field and found systematic fluctuations which must be of external origin. Today we know that these fluctuations are caused by the solar wind. One of the first recorded solar storms was the Carrington event in 1859. In 1910 it was discovered that the Sun itself has a magnetic field. Solar winds have been observed more precisely since the 1950s. Right after World War II, the United States used captured V-1 and V-2 rockets to carry out the first measurements of the X-ray emissions and ultraviolet rays of the Sun. Thereby it was possible to prove that the Sun radiates with X-rays and ultraviolet light. Both are filtered out by the Earth's atmosphere. In 1974 and 1976, the US-German Helios mission were launched. ESA's Ulysses spacecraft was launched on a NASA rocket in 1990. It was the first spacecraft to study the solar wind outside the Earth's orbit. The probe, built by the German company Dornier System GmbH, now part of Airbus Defence and Space, was in operation until June 2009. In the mid-90s, ESA launched the SOHO mission to investigate the so-called helioseismology. Helioseismology is the study of the interior of the Sun through observations of the wave propagation of the Sun's rays. The probe was positioned in Earth orbit at what is known as Lagrange point 1. There, the probe is at an optimal distance from the Earth and the Sun so that the gravitational forces of the two celestial bodies negate each other. In 2006, the STEREO mission was launched. The NASA mission investigates the events that are triggered on the Sun and have effects throughout the solar system. For this purpose, the entire area between Sun and Earth is observed. Since 2010, the SDO mission of NASA conducts a high-resolution observation of the Sun, sending a DVD's volume of data back to Earth every minute. NASA's Parker Solar Probe was launched in August 2018. After 80 days of travel and a distance of 28 million kilometers, it was closer to the Sun than any spacecraft before. From the analysis of the data, scientists hope to learn more about the Sun's atmosphere. Why is the corona, the outer atmosphere of the Sun, much hotter than the layers below? Physically, the plasma of the corona should not be millions of degrees hotter than deeper layers. Also, many theories about the electromagnetic fields are to be verified. After 7 swing-bys at Venus, Parker Solar Probe will reach its closest point to the Sun, called perihelion, on Christmas Eve 2024. Solar Probe is humanity's first probe to fly through the atmosphere of a star. ESA's Solar Orbiter was launched in February 2020. With a total of 8 swing-by maneuvers at Venus, Solar Orbiter is intended to fly as close as 42 million kilometers to the Sun. SpaceX's development and research work also has an impact on solar explorations. By reusing rocket stages, the price of a rocket launch is falling rapidly, and with it the cost of a research mission to the Sun. The space between Sun and Earth is not empty. It is filled with solar wind. When comets pass the Sun, the particle streams of the Sun influence the tail of the comets. But near the Sun there is evidence of dust-free zones. Here, very probably, all dust particles are already evaporated. The solar wind flows around all objects in the solar system and consists of ionized hydrogen, 8% helium, 4 atomic nuclei, and single ionized atomic nuclei of other elements. The solar wind covers about 150 astronomical units. This is 150 times the distance between Earth and Sun. Beyond this, the interstellar space begins. In recent decades, we have learned how solar winds influence Earth. Thanks to technological advancements, we are no longer just observers of these influences, but can now model when they will occur and take appropriate precautions. As important infrastructure systems, such as the power grids and communication networks, can be disturbed or even destroyed by the solar wind. For example, solar winds and the electrical fluxes of the aurora borealis can lead to corrosion in oil pipelines in the long term. Therefore, above-ground pipelines are secured with a counter voltage of a few volts. When a solar storm hits the Earth's atmosphere, it changes the atmosphere's density. When the solar storm flows through the Earth magnetic field, the opposite-poled magnetic field of the solar wind affects the Earth magnetic field. Thereby, electromagnetic particles of the Earth's magnetic field are shot into the magnetosphere. There, they are trapped in electric fields and flow towards the Earth's poles. This is the birth of the aurora borealis. However, this can also lead to brief disconnections from satellites and can also cause satellites to sink several kilometers towards the Earth. The solar wind needs between 12 hours and 5 days until it hits Earth. Our observations of the Sun are now of such quality that we can be warned of a solar storm several hours after it has broken out. This can protect important infrastructure should a solar storm become dangerous for Earth. Solar storms have already caused disruptions and damage. In 1989, a super solar storm caused power outages in Canada and other parts of the world. As the Sun will have a large number of sunspots in 2022, it increases the chances for a super solar storm that can hit Earth during the next decade. A recent study of Sangeeta Abduyoti at the Donald Brent School of Information and Computer Sciences shows how vulnerable the internet infrastructure is. According to Abduyoti's study, a super solar storm could cause massive damages and disconnect several countries and continents from the internet for months. Thus, Electromagnetic solar storms have a direct impact on our lives, whether they affect our technologies or produce the aurora borealis. When you look at the vast sky at night, you will find the moon as a beacon adorning the sky. 4.5 billion years ago, the newborn Earth collided with the protoplanet Theia. The debris of this collision formed the Moon. The Moon orbits the Earth as only permanent natural satellite every 27 days and always shows the same side. The Moon has a synchronous rotation with our planet in a distance of 384,000 kilometers. But beauty for the sky is not his only gift. What would happen for the Earth if the Moon does not illuminate the dark sky? Did it just sink into the darkness at night? Without the Moon, the Earth's axial deflection of 23.4 degrees would be changing constantly. Seasons and climates would change drastically because it is the axial deviation of the Earth that causes seasonal and climatic changes. The relatively stable climate on Earth is due to the presence of the Moon. The radius of the Moon's orbit around the Earth is approximately 380,000 kilometers. The radius of the Earth's orbit around the Sun is with approximately 115 million kilometers 400 times larger than the radius of the Moon's orbit around Earth. A deviation of 5 degrees of the angle between the Earth's and Moon's orbital planes is responsible that we not see a solar eclipse every month. Only 2 or 3 times a year the Moon gets close enough to the line between Earth and Sun and a total solar eclipse occurs. When a total solar eclipse appears, the Moon covers the Sun almost completely. One of the first recorded solar eclipses is from 1900. This visual phenomenon will not continue in the far future, as the Moon's distance to Earth is gradually increasing by about 2.5 centimeters per year. A small amount of the Earth's rotational energy is stolen by the Moon. This causes the lunar orbit to enlarge, and our planet slows down its rotation speed by 1.5 milliseconds per century. This causes changes to the length of a day on Earth. About 4 billion years ago, a day on Earth was only 10 hours long, increased to 24 hours nowadays, and as this trend continues, a day will increase to be 35 hours long over the next 4 billion years. Eclipses also occur on other planets like Jupiter. Due to the multiplicity of moons, multiple eclipses occur. A solar eclipse on Pluto occurs periodically and at intervals of more than 100 years. A trip to the Moon is the most exciting journey that mankind has ever experienced. Apollo 11 reached the Moon in 3 days, 3 hours and 50 minutes. The ESA space probe SMART 1 was the slowest spacecraft to reach the Moon in 2004. SMART 1 needed 13 months to reach the Moon with its ion engine, but made it the most fuel-efficient spacecraft ever. SMART 1 orbited the Moon for 2 years and made the first detailed survey of chemical elements on the Moon's surface. In 2006, on its way to Pluto, the New Horizons space probe fulfilled the fastest flyby at the Moon in just 8 hours and 35 minutes. But nothing is as fast as the light, for example, of powerful flashlight that reaches the Moon in just 1.3 seconds. In 1609, Galileo was the first to observe the details of the lunar surface with a telescope. Galileo made topographic diagrams of the Moon and estimated the heights of the mountains.
Well, in my left hand I have a feather, in my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the Moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the 2 of them here, and hopefully they'll hit the ground at the same time. How about that?
How about
Which
that?
proves that Mr. Galileo was correct in his findings.
The Moon has a crust of about 50 kilometers and shares nearly the same isotopic compositions with Earth. Its structure is made of silica, alumina, lime, iron 2 oxide, magnesia, titanium dioxide and sodium oxide. His core is rich of solid iron. The most visible topographic feature is the giant Farsight South Pole Aitken Basin with a diameter of 2,240 kilometers and 13 kilometers deep. The lighter surfaces of the Moon are the highlands. They are composed of anorthosite, a basaltic rock of solidified magma and lava. The highlands are the older part of the Moon surface. The dark lunar plains of the near side are called Maria. They are solidified pools of basaltic lava created billions of years ago as a result of lava streams of the Moon's volcanic activities. The far side has not been affected much by mare volcanism. Imagine if one day you walk on the Moon. One of the first interesting things you see is that your shadow is much darker than on Earth. This is because the atmosphere on Earth scatters some of the light. However, the atmosphere of the Moon is very dilute. We can even say he has no atmosphere. Light that reaches the Moon forms much darker shadows. Another interesting thing is that no sound can be heard on the Moon. Sound is a mechanical wave and needs a material environment to propagate, but without atmosphere, we have no way to transmit sound. The Moon is also exposed to high-energy cosmic rays and has no shield. Footprints on the lunar surface, as well as the over 300,000 impact craters, will remain forever, unless a collision with a celestial body can erase these traces. The Moon is not geologically active, so earthquakes or volcanoes cannot destroy its surface. So-called lunar swirls are enigmatic features found across the Moon's surface. They mostly optical appear in characteristics of regoliths of 2 to 20 meters size. Regoliths keep storing atoms of the solar wind such as helium, neon, carbon and nitrogen. After the finding of water in melt inclusions of one of the NASA rocks samples in 2011, the Moon Mineralogy Mapper found definitive evidence of water ice on the Moon's surface in August 2018. The Moon dust is made on small particles from comets. The areas of the Moon that are exposed to sunlight are changing. Always when the Moon changes its position relative to the Sun, the brightness of the Moon changes, we observe a bigger or smaller moon crescent. During the time when the full moon is visible in the sky, the hemisphere of the Moon visible from the Earth is fully illuminated by the Sun. Some permanently dark and cold craters on the poles are excellent sites for infrared and radio telescopes. With the help of carbon nanotubes and epoxies, mirrors with a diameter of up to 50 meters could be installed in the Moon craters, but this was not realized till today. Find more Space Friday content on our website and social media channels on Vero True Social, Twitter, Instagram, Facebook and YouTube. Reaching the Moon first was the aim in the space race between the Soviet Union and the United States during the Cold War. The unmanned Luna 2 of the Soviet Union reached the Moon first in September 1959. Luna 3 made the first photographs of the far side of the Moon, followed by the first successful soft landing of Luna 9 in 1966. The lunar missions between 1970 and 1976 brought rock samples back to Earth. Luna 24 was the last Soviet mission to the Moon. The Apollo program of the NASA reached the Moon with Apollo 8 in 1968. Only 1 year later, in July 1969, the crew of Apollo 11 with Neil Armstrong, Michael Collins and Buzz Aldrin landed on the Moon.
Tranquility Base here. The Eagle has landed.
Several missions brought moon rocks back to Earth. The crew of Apollo 17 last visited the moon in 1972. The Japanese spacecraft Titan landed on the moon in 1990. Chang'e-1 was the first Chinese space probe reaching the moon orbit in 2007, Chang'e-3 in December 2013 and Chang'e-4 in 2020, where the first space probes landed on the moon for 40 years. In 2018, SpaceX, Vodafone, Nokia, Audi announced to install a 4G wireless communication network on the moon. With Apollo 15, humans left the fallen astronaut memorial on the moon, a symbol for the astronauts who helped with space explorations and lost their lives along the way.
The Apollo 1 crew caught fire during training. The Russian cosmonauts of Soyuz 11 were killed while returning to Earth, and Soyuz 1 cosmonauts Yuri Gagarin and Vladimir Komarov died later during test flights on Earth. The Outer Space Treaty from 1967 forms the basis of international space law, including the Moon and other celestial bodies. In this spirit, no country claims ownership of any part of the Moon.
It's one small step for man, one giant leap for mankind.
Space. We crossed the frontier of our solar system, investigated exoplanets and the Kuiper Belt. Now we are back in the neighborhood to explore the biggest of all mysteries and to investigate the future of human space travel. Space Friday, Season 3 coming in 2022.